In this video, we will learn variation of parameter. The method of variation of parameter is used to solve the non-homogeneous differential equations if y1 is a solution of homogeneous differential equation. That means if we know the solution of homogeneous differential equation, then we shall use that equation, that solution, to find the solution of non-homogeneous equation in the method of variation of parameter. For that purpose, suppose y double dash plus pxy dash plus qxy equal to 0 be a homogeneous equation and y double dash plus pxy dash plus qxy equal to rx be a non-homogeneous differential equation Suppose yc equal to c1y1 plus c2y2 be the solution of equation 1. We shall use this solution to find out the solution of non-homogeneous differential equation, that is equation 2, by using the variation of method of variation of parameter. In this solution, y1 and y2 are linearly independent. y1 and y2 are linearly independent in the interval a less than x less than b. That means open interval AB. Now, here we replace equation 3 by some other equation. Replace this C1 and C2 constant by some variables, functions. Therefore, if y equal to, instead of C1 we will write a1x y1 plus a2, instead of this we shall write, if y equal to ax y1 plus bx y2. We shall consider this as a solution of the non-homogeneous differential equation. Now, for that purpose, we have to reduce the order. If you put bx equal to 0, what happens? We will go to the method of reduction of order of the differential equation. Therefore, we shall not use bx equal to 0 or ax equal to 0. We shall use some another condition. We shall apply some another condition on this equation so that we will get the solution of the second equation. Now, if we differentiate this equation, what we will get? Y dash equal to ax y1 dash plus bx y2 dash plus a dash x y1 plus b dash x y2. We will get y dash equal to this. Suppose this is equation 5. Here If we impose a condition, suppose a dash x y1 plus b dash x y2 equal to 0. If we impose this condition on this differential equation, then what happens? Y dash becomes ax y1 dash plus bx y2 dash. And if we differentiate again this, we will get ax y1 double dash plus bx y2 double dash plus a dash x y1 dash plus b dash x y2 dash. Equation 7. If I use all these equations in equation 2, what happens? From equation 2, substituting these values in equation 2, we will get y double dash. Y double dash means ax y1 double dash plus bx y2 double dash plus a dash x y1 dash plus b dash x y2 dash plus px into y1 dash y dash. Px into y dash. Y dash is nothing but y dash x is ax y1 dash plus bx y2 dash plus qx. Y is nothing but ax y1 plus bx y2. This is equal to Rx. Now we shall rearrange the terms in this equation. Rearranging the terms, ax y1 dash plus px ax y1 dash plus qx ax y1 dash. What we will get? Ax is taken common, y1 dash y1 double dash plus px y1 dash plus qx y1 plus bx y2 double dash bx y2 dash px into bx y2 dash and qx into bx y2. From this we can take bx common and again y1 double dash, not y1, y2 double dash plus px y2 dash plus qx y2 plus remaining terms. Remaining terms are a dash x y1 dash, b dash x y2 dash. A dash x y1 dash plus b dash x y2 dash equal to Rx. Now, as y1 and y2 are solutions of the homogeneous differential equation 1, that is px, that is y double dash plus pxy dash plus qxy equal to 0. What we will get? This bracket is 0. y1 double dash plus pxy1 dash plus qxy1 equal to 0. Similarly, y2 is also solution. Therefore, y2 double dash plus pxy2 double dash y2 dash plus qxy2 is also 0. Therefore, this two term vanishes and there remains only a dash x y1 dash plus b dash x y2 dash equal to rx. This is equation number 8. In equation 6, a dash x y1 plus b dash x y2 equal to 0. And in equation 8, a dash x y1 dash plus b dash x y2 dash equal to rx. Therefore, these two equations can be solved for a dash and b dash. And this happens, equation 6 and equation 8 can be solved to obtain a dash x and b dash x. This happens if the Jacobian y1, y2, y1 dash, y2 dash is non-zero. And since y1 and y2 are linearly independent, this is non-zero. Since y1 and y2 are linearly independent, since y1 and y2 are linearly independent, Wronskian W equal to determined y1, y2, y1 dash, y2 dash does not vanishes. And hence a dash x and b dash x can be obtained. Integrating we will get ax and bx. Therefore, particular solution is y equal to ax y1 plus bx y2. Thus, we can obtain particular solution of the given non-homogeneous differential equation by using method of variation of parameters. We shall see one example, or we shall solve one example by using this method.